250 miles above Earth, even growing a leaf becomes an engineering problem.
On Earth, gravity quietly helps control water, air, and the environment around a plant's roots.
Yeah.
Up here, that assumption disappears. The first challenge is not the leaf. It is delivering moisture to the roots without letting water behave unpredictably around the spacecraft.
So cultivation begins with control. The seed, its rooting medium, and every small component must remain exactly where it is needed. Once prepared, each module is fixed into a controlled growing environment where light, airflow, and moisture can be managed together. Root zone moisture initiating.
Confirming contained flow, no free water.
Verified. Shutting down pump and sealing.
Then comes an artificial day. LEDs provide the wavelengths and timing the plants need, while using far less space than sunlight would demand.
After germination, the first shoots appear, small, uneven, and fragile. From this point,
airflow matters as well. Without normal convection, moving air helps manage the small environment surrounding each leaf. What looks like a small garden is really a controlled ecosystem. Water, light, airflow, and human care working together to keep a crop alive in orbit.
Once the seedlings emerge, the work becomes observation. Small differences in color, shape, and growth can reveal whether the environment is behaving as intended.
Plants still respond strongly to light. In orbit, that controlled illumination becomes one of the signals helping shape how shoots and leaves develop. The root zone needs a careful balance. Moisture must reach the plant, while enough gas remains available around the roots for healthy development. Adjustments are deliberately small. In microgravity, water does not simply drain away beneath the roots. As the canopy thickens, moving air becomes increasingly important. It helps prevent a stagnant layer from building around the growing leaves. Over time, those first shoots become a canopy.
Yeah.
More leaf area means more photosynthesis fume, but it also individual leaves are checked closely. Texture, color, and shape provide simple visual clues about how the plants are coping with their controlled environment. Because the crop may eventually become food, handling has to be controlled as carefully as the growing conditions themselves. Growth also changes the geometry of the chamber.
Right.
Leaves need room to expand without blocking access or interfering with the systems around them. By now, the experiment has moved beyond germination. The challenge is to keep these conditions stable long enough for a small collection of leaves. As the plants become larger, keeping them alive is no longer enough. The growing environment has to remain stable while the crop itself keeps changing.
Space is another resource. As leaves spread outward, the crew must make sure the crop can develop without interfering with the hardware that keeps it alive.
A larger plant demands more from its root zone, but in orbit, adding water still has to be controlled with far greater care than simply pouring it into soil.
Leaves also exchange gases with the air around them. Without gravity-driven convection, continuous airflow helps prevent that local environment from becoming stagnant.
As the canopy becomes denser, light has to reach a changing three-dimensional structure, not a flat row of identical leaves.
Human care remains part of the system. Simple interventions can expose hidden growth and help the crew inspect areas that would otherwise disappear inside the canopy. Temperature, humidity, airflow, and lighting form a tightly linked environment. A change to one condition can alter how the plant responds to the others. By this stage, the crop is no longer a collection of tiny seedlings. It has become a substantial living volume that the hardware must continue to support. The plants are now approaching maturity, but before anything can be harvested, the crew must keep this small ecosystem stable through its most demanding stage of growth. As the canopy fills the chamber, environmental control becomes more demanding. The plants themselves are now changing the conditions inside this tiny growing space. Every leaf releases water vapor. As leaf area increases, humidity becomes part of the engineering problem rather than simply a background condition. The denser the crop becomes, the harder it is to move air evenly through it. Stagnant pockets around the leaves are exactly what the system is designed to avoid.
Light now has to penetrate several layers of foliage.
The upper leaves intercept more of it, while growth deeper in the canopy receives less.
Above the roots, the crop may look healthy, but the hidden part of the system still depends on carefully controlled moisture and access to air.
On Earth, excess water tends to move downward. In microgravity, that familiar drainage cannot be taken for granted.
Even routine plant care changes when the gardener cannot simply stand beside the crop. Before making a precise adjustment, the crew first has to stabilize themselves. There is another rule that terrestrial gardeners rarely think about. Nothing can simply be put down. Every small tool has to stay secured. No single measurement tells the whole story.
Healthy growth depends on the leaves above, the roots below, and the controlled environment connecting the two. Keeping a crop alive in orbit is not one problem solved once. It is a continuous balance. Light above.
Weeks after those first shoots appeared, the crop is approaching maturity. The engineering challenge now becomes a biological result that can be seen leaf by leaf.
The plants are not identical. Differences in size, shape, and orientation are part of a living crop harem,
And even close to harvest, the hidden root environment still matters. A healthy canopy depends on conditions that remain largely out of sight.
a mature canopy creates its own crowded microenvironment. Moving air through those overlapping leaves remains essential right up to the end of the growth cycle. Harvest begins with selection. Mature edible leaves can be identified while the rest of the plant remains secured in its growing position.
One controlled cut with the leaf captured immediately.
Once removed, the leaf is contained immediately. In orbit, good agricultural handling also means preventing food, tools.
For the first time in this cycle, the result is tangible. Fresh edible leaves produced inside a spacecraft from a carefully controlled engine.
Healthy leaves can make the process look effortless. But beneath them, microgravity is still changing one of agriculture's most basic.
Without normal gravity-driven drainage, water can remain where surface forces hold it. The challenge is to distribute moisture without leaving the roots short of oxygen.
Roots need both water and oxygen. Managing one without blocking the other is a central problem when
Corrections are measured rather than dramatic. The goal is not to flood the roots, but to keep the root environment within a range the plant can use.
Plants have evolved with gravity, but gravity is not their only guide. Light and other biological signals still influence. Even a tiny loose fragment matters in a spacecraft. Plant material that would simply fall to the floor on Earth has to be captured and contained here.
The objective is stability. Small adjustments, careful handling, and continuous monitoring allow the growth.
After weeks of controlled growth, the experiment has produced something immediately recognizable: a small crop of fresh edible leaves, ready for careful harvesting.
Now the process changes again. Growing gives way to harvesting done. But in microgravity, even removing a leaf has to be treated as a controlled operation.
Harvest begins one leaf at a time. The cut is simple, but the leaf must remain controlled from the moment it leaves the plant. On Earth, a harvested leaf can be placed on a bench. Here, it moves directly into containment because there is no floor waiting beneath it. Selective harvesting protects the rest of the plant. Mature outer leaves can be removed while younger growth remains attached and biologically active. The objective is not to strip the plant bare. Leaving healthy growth behind preserves a living biological system. The harvested material is checked just as carefully as the plants themselves. What matters now is whether controlled growth has produced healthy edible tissue. Growing food is only part of the process. Once harvested, the crop still has to be handled cleanly and kept contained before it can become part of a meal.
The quantity is modest. That is the point. This is not a field in space of whether fresh food can.
The chain is now complete. A seed held in a controlled root zone became a living canopy, and part of that canopy has become fresh food. The harvest ends the way the growing process began, with control. The food is secured, the tools are restricted. One final leaf completes the harvest, while the plant itself remains rooted bone, still alive inside a laboratory hundreds of kilometers above Earth. For crews accustomed to food carried from Earth, fresh plant material offers something different. Food that has completed its entire growth cycle inside the spacecraft. The quantity may be small, but the connection is immediate. Something planted, monitored, and harvested in orbit can now become fresh food for the crew who grew it. For missions that travel farther and remain away longer, carrying every fresh item from Earth becomes increasingly difficult. It is only a small garden. But beyond Earth, learning how to grow even this much may help determine how far human crews can eventually go.